So the first thing I need to do is identify what my A, H, and K is. In this case, my A value is 1, my H value is 0, and my K value is 1. There's no H value because there's nothing tacked on underneath the radical sign. So from here, I just have to go ahead and plot my generic, my parent function of y equals 1 root x. And if you remember, that would be 0, 0, 1, 1, and 4, 2. Oops, that has to be copied. There's my parent function. From that, I have to shift everything 0 left and right and 1 up. Yes, sir?
How do you find those?
What are perfect squares? 0, 1, 4.
Do we always do the K?
What's that?
Whatever it's called, you know how we did like the opposite or whatever it's called, like switch or something. Shift K.
The shift? Yeah, there's always a shift.
I know, we always put that in there.
Yeah. You always graph the parent function first, and when you do the parent function stuff, you're usually looking at your, whatever. This is pretty cool. Cool, I like it. So from there, I take those 3 points and I shift them all up 1.
Yeah, for sure.
And there's my new graph. And that's it. Remember, the dotted line represents your A root something. The solid line is going to be your shift. Okay? The solid line will represent your shift. Yeah. There's a way over here. 18, let's say 1. Okay. On 18, you have to be careful with your exponent rule to understand what has the cube root. Well, in this case, the only thing that has the cube root is the x. So in here, it would be the same thing as writing out. Mama, come on. It's the same thing as writing out like that. So now when I go to identify my A, H, and K, my A value is 2, my H value is 0, my K value is -3. Your parent function for a cube root, remember you're always going to be using 1, -1, and 0. I know it's going to go through 0, 0. Cube root of 1 is 1. 1 times 2 is 2. So at 1, it's +2. And then it's going to be the other direction, this way. So here is my parent function. What are perfect cubes? 1's a perfect cube. What's the cube root of 1? What's 1 times 2? So it's at 1, 2. That's my parent function. I do that for both 1 and -1. Now with those 3 points, I shift them. In this case, they all have to move down 3. Yeah?
Why did you do negative there in the last one?
I can't use a negative of the square root. So here, I just move everything down 3 spots. So we'll go and there's your shift. Remember, parent dot is dotted and your shift is solid. What else?
Let's do 90.
Are we just asking last night?
I just want to talk. I'm going to start with these, then I'll start going over all the rest of the junk here in a second.
The first 4 on this.
What's your A, H, and K?
A is 1.
A is 1, H is
7.
K is
Nothing.
0. So you start your graph by plotting your parent function. In this case, it's just A square root x. So it's going to be at 0, 0, 1, 1, 4, and 2. To those points, I have to move them where? 7 to the right. Very good. I just move all of these points 7 spots to the right. So here's 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, and 2. And there's my new graph. Yeah, it's, I know the scale on that one is counting by twos. It's just, you gotta pay, sometimes they try to give you a little space, sometimes they don't. Okay. The other side is really basically the exact same stuff. There shouldn't be anything too scary. Just remember on number 17, if you're looking at 17 on the other side, when you have f of x is 1 minus the square root of x, that's the same thing as saying negative 1 root x plus 1. So your a value is negative 1, your h is 0, and your k is 1. That's the trick on that one. Use the commutative property to move stuff around. That's 17 on the other side, the 110 side.
So, like 1 minus.
Okay.
Wait, can you explain that again?
What's that?
What you just did?
All I did is just moved it around to use the commutative property of addition. 1 minus root x, the same thing as negative root x plus 1. So I just put it in that standard form so that way I know that my a value is negative 1. That's all. Mr. May?
What do you find it? Or what do you find it?
How do I find a?
Why?
Why? That way I know what my, I call it my amplitude. How high, how fast it's rising or how fast it's declining. This generic curve can be shifted around to go up quicker or slower depending upon what it's set at. And it being negative means it's going the other direction. That's all. You'll see a values a lot more later on too. Graphing not so bad. All right.
Yeah.
All right. What else we got here then? Where do you want to start?
I just want to see the answers to all of them. So wait, just look at the answers. I just know.
I have the answer sheet for the one that's stapled. I didn't get a chance to do an answer sheet for this one. I didn't get a chance for that.
Could we?
If you give me to the end of the day, I can make a copy of it real quick, and I'll have it in here by the end of the day.
That'd be really nice.
Yeah, guys, if you want, what I'll do during lunch is I'll make an answer key for this, and I'll make some copies of it. So if you walk by again, I'll just throw them on my desk and just grab one. Okay? Yes, sir.
How do you determine the range?
Range. The range is all possible y values.
Yeah.
So
like, is it always gonna be like y is gonna be greater than 4?
which one?
17 for C.
Oh, okay. On 17, I didn't graph that one yet. So in this case here, if we go to graph this one, you have your a value is negative 1. So I'm going to, my parent function is going to be y equals negative 1 root x. So it's going to be at 0, 0. At 1, it becomes negative 1, because it's going the other direction. And then at 4, it becomes negative 2. So this is the parent function. To that, there's no horizontal shift, but there is a vertical shift going up 1. Do you agree?
Yeah.
So my new starting point is at here, here, and here. So this is the curve that I worry about my domain and range. So for the domain, what is the smallest possible value of x? 0. So my domain has to be greater than or equal to 0. With the range, with this curve going down to the right, what is the highest possible value of y? 1. Y is going to be less than or equal to 1.
So it's basically if it once it crosses the y-axis.
Yeah, it doesn't matter where it could be. This point could be out here somewhere over here at like -6 and 8. So it just depends on where that endpoint winds up as to what your domain and range is going to be bounded by. Okay. When you're dealing with the cube root functions, you don't have to worry about your domain and range. It's the domain and range of the square root or your even powered ones that you'll have to more worry about.
Yeah, if it's cube root, isn't it any number?
Yeah, it's all reals.
So D is like the.
D is your x values, and R is your y values. Okay. So, yeah.
Oh,
No, go ahead.
okay, it was a business trip.
Uh-huh.
One of the answers was the forces of x over 2.
Yes. 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 And I want to show that, I'm going to get to that one. Let's do that one. I don't remember if I had one on here or not. I don't remember if I did it. Try to make sure I threw one on here. All right, let's take a look at that one. Do you have it in front of you by chance? Otherwise, I can. Yeah, I can just pull it out here. So many files. Find the inverse. If I'm not mistaken, about 4 of you got this right. Find the inverse. It's from the quiz. And there's a reason why most of you guys got this wrong. You didn't rationalize. You can't have a radical in the denominator.
Can you do 20 after?
In this case here, you have, basically you have y, you're starting with y equals 3x to the 4th. And I'm going to find the inverse, which means I have x equals 3y to the 4th. In order to solve for y, you first divide by 3, and then you have to take the 4th root. So most of you guys wrote out 4th root of x over 3. That means that there's a 4th root in your denominator, which you can't have. So with 3, this is the same thing as saying 4th root of x over the 4th root of 3. 3 is a prime number. Do you agree with me on that?
Yes.
Okay. 3 is the same thing as saying 3 to the 1st power. Do you agree with that?
Yes.
Now, how many more powers do I need of 3 to get it to 3 to the 4th?
3.
3 of them. So you multiply the top and the bottom by the 3 cubed, the 4th root of 3 cubed. When you do that, you wind up with the 4th root of 3 to the 4th, which means the radical drops out. You can just get 3 in your denominator. And what's 3 cubed? 27. So your numerator is the 4th root of 27x. And that's how that looks. Okay? I think that if it was not written as a 4th root, but as a square root, you would have caught it. You know, that's a tricky question. That's a tricky question. Okay? That's a very tricky question of that one. All right? Also, what else was on this side here? I want to make sure. When you are simplifying radicals that have, or simplifying exponents that have numbers, the numbers do not disappear, ladies and gentlemen. The numbers do not disappear. When I look at this thing, I have 25 to the 1/6 and 25 to the 2/3. Do those have the same bases? Their bases are both the same. They're 25. Who wins in the battle? 1/6 or 2/3? 2/3, because that's the same thing as saying 4/6. So when I write that out, I get 1 over 25 to the 3/6, which is the same as 25 to the 1/2. And what does 1/2 power mean? So you get 1/5.
Wait, so we didn't simplify it, we got it wrong.
Yep.
That's not also not the same.
No. Now, also when you get into stuff like this, you have to pay close attention to your exponents. A lot of you guys are still leaving negative values in your exponents. Negative values on exponents is bad. Very bad. What do I say about that?
Wait, I don't get how 25 over 25 equals 1 over 25.
If this was x cubed over x to the 5th, do they have the same base? What is it? X. Who wins in the battle of the war, 3 or 5? 5. So when you simplify that out, you get 1 over x squared. Do you agree? Okay? So these guys have the same base. Same rules apply. And that's usually the trick that a lot of people have problems with. Because it's tough to differentiate between variables and numbers because you're not accustomed to it. That's why I kept saying the same base, just follow your exponent rules. Yes, sir.
Those ones was on the worksheet.
Okay.
It was number 12. It was f of x over g of x. And it was x minus 1 over x plus 1. So.
Okay. So this is, he's looking at page 110, guys, number 12. So you wind up with x minus 1 over x plus 1.
So is it 0?
Can I do anything with this?
No.
You're done.
That's it?
That's it.
Okay.
There's nothing you can do here. Okay. There's nothing you can do here. When it said that, state the domain, what is the only value of x that this doesn't work?
Negative
Negative what?
number.
Which number? There's a lot of them.
It's negative 2.
Oh, if negative 2, then it would work.
No.
What happens here when they're asking about what is the domain for this one? Notice if I substitute negative 1 in for x, I get 0 in my denominator, right?
Yeah.
Can't divide by 0, can I? So your answer would be, your domain would be all real, not negative 1. Could be any answer but negative 1. There's what you call an asymptote there. And we deal with a lot more of that style problem in chapter 9, which we'll start on Monday. Don't worry about having to state domains and ranges out of that function notations tomorrow. You don't have to worry about that. Okay? Yes, ma'am.
Can you use 17 in place?
17 from the quiz. You have the fourth root of 18x. Oh, excuse me, this didn't write out very well. So we have the fourth root
Oh, I think I realized it.
of 18x to the 8th, y to the 9th. And is that z cubed? Yes.
I figured it out.
Well, I might as well do it anyway.
Yeah, just do it.
So when I start this problem out,
Took away the cube.
put the cube back first. Remember, that means you're taking the fourth root of each individual part. Is there a perfect fourth root that goes into 18? No, so that will stay in. Yes, sir? So I know that the fourth root of 18 is going to stay in there. Then when I start dealing with my exponents, this is the easy part. 4 goes into 8 how many times? Is there any left over?
No.
So 2 come out. 4 goes into 9 how many times? Are there any leftovers? 1. So 2 come out and 1 stays in. Does 4 go into 3?
No.
So all 3 of those stay in. And you're done. Yes, sir?
Can we move on?
I just had a question on that one.
Oh, no.
Okay.
Could we do one of the,
What do you got? Hold on. He was
can we do 6 on 110?
6 on 110. Okay, give me 1 second.
It's a similar problem, but I think.
Yeah, you did all right. 6 on the 110, you said? And I left my paperwork back here. Thank you. Number 6 on the 110. You're right, it is very similar. We have the fourth root of 32, x to the 5th, y to the 4th. So now I have to start thinking, is there a perfect fourth root that goes into 32? What is it? 8 is,
No, 8 is on the fourth root.
what's 2 times 8? 16. So 16 goes into there, correct?
Yeah.
So what's the fourth root of 16? 2. So I can take a 2 out. What's left then? Good. Now do your exponent rules. 4 goes into 5. How many times? Once. How many are left over? And then 4 goes into 4. How many times?
Cool, thank you.
And you're done. Does that make more sense?
Yeah, I just want to see you simplify.
Yeah. When you're breaking apart that 32, you want to keep it in, it's 16 times 2 because those are your fourth roots. That 16 is that perfect fourth. Okay.
Would it be 2 to the 4th?
No, because I took out 2 to the 4th, because the fourth root of 16 is 2. Just like you did earlier, if I took the square root of 12, that's the square root of 4 and the square root of 3. It didn't stay 4 squared outside, did it? No, it just became 2. Okay. It's just because you have to think about it on a fourth one here.
Can you do number 16 on the quiz?
What is the cube root of 8? 2. So I have 18 times 2. What is the cube root of 27?
3.
What's 18 times 2?
36.
Not down 10, is it 25?
No, I didn't.
Oh, never mind. Wow, that was bad.
Wow.
So on my I don't know, I didn't see that it was a negative half. So then I had it as 125 for the half, and I didn't understand, I didn't see it as a double. Wow, that's pretty good.
It's just early in the morning, isn't it? It's cold. Your brain's frozen. So. Yes.
Could you show us how to do the first one on the assignment?
Yeah.
Because I
On the
couldn't-
staple chart?
I couldn't understand.
Okay.
Understand that.
On the first one on the stapled one,
Yeah.
And then you want to do the exponential form.
And possibly number 4 as well.
in this case here with the function notation, it's basically telling me to start with the innermost problem, which is h of -2. After I find a result for that, I'll take that value and substitute it into the g equation. So when I substitute -2 into this, I get 4 times -2 plus 3, which gives me, what is that, -5? From there, I take this -5, and I'm going to substitute now into here and here. So it becomes -5 cubed plus 4 times -5. -125 and -20 is -145. Does that make more sense?
Yeah.
It's telling you, substitute that value in and go and work your way out of it. Work your way out.
Can you do number 6?
Same one?
Yeah.
Find the inverse? Okay. Find the inverse. So we have, I'm going to write it as y equals -1 over x minus 1 minus 2. That's my starting point. What's weird when you have these negative values in front of a fraction, remember, it can be negative in the numerator or in the denominator. I usually, when they put it in front like that, I usually just negate the numerator. I think it's always been easier that way. So from here, I'm going to flip-flop my x's and y's. So I have x equal -1 over y minus 1 minus 2. So to start this, excuse me, I have to add 2. To start this, I have to add the 2. Now, after that,
Wait, that should be positive.
Yeah.
On top should be positive. Oh, sure. But
Do
that's
you
not-
multiply by y minus 1?
yeah. So now this side has dropped out. Do we agree? From here, I have y minus 1 times x plus 2 equals negative 1. Do you agree? I'm not foiling, I'm not doing anything. I'm moving the screen up so we can see. From here, before I do anything, how do I move the x plus 2? Divide it out. So now I have y minus 1 is negative 1 over x plus 2. And then lastly, what do I move? The 1. So your final answer is y equals negative 1 over x plus 2, all plus 1. That's a good question. I like that one.
So one like that?
I don't remember.
You remind me of the show.
Could we do the?
Please don't put me in reminding me of him.
Yeah, he doesn't even see it.
Well, at least I.
At least he makes something.
No, you're
What?
not on the same level.
I'm a lot taller.
I'm a lot better of a teacher.
Can you do 11 for the quiz?
Sure. Slowly but surely we'll get there. Number 11 from the quiz. In order to be able to multiply these two guys together, I have to get the same roots, the same nth root. So it's kind of like forcing you into simplifying out the cube root of 40. You want it to turn into a 5. So it's 8 times 5. Do you agree? So I have the cube root of 8, cube root of 5, all times 4 cube root of 5. What's the cube root of 8? 2. So I have 2 cube root 5 times 4 cube root 5.
Just do that. 2 times 4 is 8.
8 cube root 5. Okay. Let's see, what else we got on here? Simplify, simplify, simplify. There were a couple of solvings. I mean, I'm trying to remember if there was really anything scary on the solvings here. If I look at number 26, I figured most of you guys would freak out when you saw this because it looks scary. Again, when I start this problem, it looks very, very frightening. But what am I going to do first?
Add 6.
I'm going to add 6 to start off. So in my calculator, I'm just going to take negative 191 over 32, add 6 to it. And create my fraction again, because it might be helpful. When I add 6 to both sides, I wind up with 1/32 equals x minus 8 to the negative 5/6. Now I have to get rid of that negative 5/6 exponent. I need to turn it into a positive 1, which means I'm going to multiply by its reciprocal. What's the reciprocal of negative 5/6? I don't want to say multiply, but raise it to the power of its reciprocal. What's the reciprocal of negative 5/6? Negative 6/5. Good. So I raise this to negative 6/5, which means I raise this to negative 6/5. So in your calculators right now, you should have 1/32, I'm assuming. Yes, sir.
I have negative 383
You probably didn't write negative. Yeah, you borrowed this assignment. It should be negative. When you
I
add,
got the right answer.
Oh. Well, let's see what well, I haven't raised it. I haven't switched powers yet.
Okay.
So these powers basically drop out. You get an exponent of 1. So you have x minus 8. On the left side, if I raise that to a negative 6/5, I get 64. Add 8, we get 72. Do you get 72? Yeah, I guess so. All right. You might have just written it up a little bit differently and simplified it out. I mean, it's not the end of the world. Okay. What you did you get a common denominator and just did it by hand? Is that why? So remember, sorry, Paige. Go ahead.
This doesn't have to do with that.
So what do you got?
Okay, well, I put negative 7 squared into my calculator, and that's negative 45.
Parentheses. Remember, because the calculator is thinking opposite of 7 squared. You got to group it with parentheses. Otherwise, it'll be wrong like that all the time. But at least you caught it. Does that make sense? Mr. West, I know you had your hand earlier.
Could we do the 4 on the two sides, the statement sheet?
Number 4?
Yes. It was the h of x
I got it.
equals.
I got you. So h of x is 4x minus 2. G of x is 4x, oh, excuse me, x squared minus 3x. Find h minus g times 8.
Let's multiply by 8 does that mean put in 8.
Yeah, that's when you're putting it in like that one. So you subtract them, then you substitute in 8. So if you subtract these two off, you've got 4x minus 2 minus x squared plus 3x when you distribute out the negatives here. And then you're substituting in 8. So you should get 4 times 8 minus 2 minus
So
8
whenever we
squared.
have like a number on the side, we just substitute it in for the variable, like the x or.
Yeah, that's what that means. So with any luck, this should be right. Negative 10? Woohoo!
Alright.
Okay. Mr. May,
When do you have to like test it or
what do you mean?
like with the line test?
Oh, when I say find an inverse of the function, it'll say function, and that means 0.
So we don't have to do it.
Yeah, I wouldn't worry about it. Okay, that's a good question, but I'm not going to make you guys have to worry about it. So we have to do this. Yeah, you're not having to worry about testing. That'll be stuff that you guys will do next year more than you will in here. So I wanted to introduce it so that way next year when you hear about it, you can say, oh, I vaguely remember that, but you'll forget.
So is that the
That's okay.
calculator?
I don't know if there's calculator or not calculator. I haven't made my final copy of the test yet. Yeah.
So please see what's on the test. I won't be able to multiply 85.
That's what it means, yeah. Yeah. Mr. Sean.
Real quick for this one.
Yeah.
Is that h minus g of 8?
Yes.
Rather than times 8?
Correct. To be honest, I would prefer to have seen this maybe with an extra set of parentheses or something.
Yeah, that would mean more.
Because I think that'd be a little bit clearer, because we haven't really done a combination then substitution. We've usually done it a little bit differently. When I put this stuff on there, I make sure that it's not something that's going to be completely out of left field. It will be it'll be easily explained, if that makes sense. Okay? There's no reason to change up too much stuff to freak you out. I'll push you, because that's what I like to do, but I'm not going to change the game in middle and make you do weird stuff. So, what else would you like to look at?
What does this
On
exponential?
this packet, well, thank you.
Yes, ma'am.
Number
Number 3. Same idea as this example here, where you have h of x is x squared plus 4x. G of x is x minus 5. When you're trying to find h minus g of negative 5, you have to subtract them out, and I bet you I know what you might have screwed up. Take your x squared plus 4x. You have to subtract x, but when you subtract the negative 5, you probably didn't write it as plus 5. Now you substitute in negative 5.
Oh, wait, where'd you get the plus 5?
I'm subtracting. So I'm subtracting x, and I subtract the negative 5, so it becomes plus 5.
Oh,
That's usually where people screwed up.
no, I was taking it as like I subtracted and got the x squared plus the 5, but then I multiplied that by negative 5. I didn't realize it was subtract.
It's a substitute, yeah, and that's what Sean was just asking over there about how will this be worded. This will be very clean. It'll be a lot cleaner than this then multiplied in. It'll be more along the lines of the ones that you see above it, where it's g of 8 to 2, that kind of stuff.
This is exponential form.
Exponential form is taking your root. If it's, let's say it's x cubed square root, exponential form, your nth root is the denominator. The root inside is the numerator. That's switching
Like
between.
way back at the beginning?
What's that?
Wasn't that like way back?
Yeah, it was the first section. It's just rewriting them back and forth. Okay.
What's an extreme solution?
Sometimes it doesn't work. So you always double check your answers. And if something doesn't work, that's when you just got. If you substitute back in, if it doesn't work, that means it's an extraneous solution.
You said there were 20 extraneous.
Well, there might be.
Well, that's what you said.
No.
You said that when, well, like, what were you talking about when you said like?
Oh, we were talking about something like this. It'll be set up where it'll be written instead of like this, be h of g. It'll be written clearer so you understand what that's.
So that I didn't
Oh yeah. Maybe. Use your time wisely, ladies and gentlemen. These review questions are really good. I will also recommend if you go on the, you go back to the website on the 7 stuff. I did put up the link for the chapter review underneath the chapter 7 once it gets going here. It's thinking. Whatever. There's chapter review problems. I spent a couple of minutes especially double checking and working through some of my exponent rules and working through some of that.
When you try to look at ours,
I don't remember what problems they are. This is not loading for some reason.
okay, yeah, I can strong side.
But I have the link to the chapter review problems to go from there. When we come in tomorrow, we'll just get going on the test right away and call it a day for the weekend.
I'm down.
I think it's about 12 problems, maybe 13. It's not that much. Yeah, it's not very long. I don't think it's very long. I didn't really, I mean,
That is actually.
all right. She's going to be stressed out no matter what. But that's okay. Yeah.
No, the whole point.
Not necessarily.